So, folks, as you walked in, we gave you a paper survey. We'd really appreciate it if you could actually complete it and just leave it on the seat where you are, and we'll pick it up. We'll pick it up from our perspective. If you're one of the people who want to do it online, that's the URL for you to do it online as well. So either way works for us. But if you're doing it on paper, just leave it here, and it's fine. So if you're here to learn about the Cloud Platform System, you're in the right room. If you're not here to learn about Cloud Platform System, you still need to stay here. There's no reason going anywhere else. This is what you want to know about. Because trust me, after this, there's nothing else. So how many of you have actually been to the booth to see the CPS racks? You have? That's great. Have you taken this thing called the Relfie? It's called the Rack Selfie. So I'm not kidding. I mean, that happens to be Ken. He's right here. He's from our team. He took a bunch of, and then of course there were a bunch of people, toying around with Star Wars lightsabers yesterday. So to come by the booth after this session, it'll be great. One of the unique opportunities to actually see these things in person. They're quite a sight. It's fun. Actually, the back of the rack is really, really neat. If you're a geek, you'll find a lot of value there. Sorry? No, we call it Relfie. It was a term actually that was invented at TechEd Barcelona when we launched. So people used to come there and take selfies with the rack, and that one actually is from Barcelona when we launched in October 2014. That is Jason Zander. He is the VP of Development for Microsoft Azure, and that is Thomas Fenning. He is the Director of Development at that point of time for Windows Server. And so we caught them taking a Relfie, and we figured we'd put it up for you to see. As you can see, I'm trying to get moving forward because I've got a lot of material to cover. I want to cover a few slides before I can actually even officially get started. So the agenda will be done before we get started. That's the agenda. We're going to talk about CPS. We'll talk about why integrated systems are useful, and then we'll dive into CPS, right? There are quite a few of us in the room, so it's probably better if we hold our questions to the end of the conversation. If I haven't answered most of the the questions that you had in the deck, absolutely, I'd be happy to address those questions at the end. All right. So, how many of you have heard of CPS? Just a quick show of hands. Okay, good. How many of you think you would have heard of CPS by the time you leave this room? That means you plan to stay awake and listen to the whole thing. All right, good. So let's get started. So I'll start by, talking about what's happening today in the private cloud space, right? And what's happening today is that about 60 to 80% of customers are failing to actually realize what they started out with when they tried to deploy a private cloud. And this isn't our statistic. This is a statistic that we've gathered from multiple customers. We've talked to Gartner, we've talked to many analysts, and all of them have come back to us with this data to say that, look, it's really hard for people to get their heads around what a private cloud is. It's really hard to build. It's equally hard to operate. And the promises that people think they're going to get out of the cloud are actually all fall apart when they actually try and set it up themselves. And so that was the genesis of why we actually started CPS. When we found out that so many customers were failing to be able to operate and deploy private clouds, we figured there has to be a better way to enable you to do that. And that is the birth of CPS. So here is what happens today, right? In today's day and age, people want everything yesterday. And that's the demand that they make of us as ID pros, right? They are used to basically going onto the web, logging onto, Box or any one of these new services that are available and be able to fulfill their demand right there in an instant. And when they come to the workspace, right, as Satya talked about, work is what you do, not where you go. When they log into the work environment and they find that in order for them to get a new instance of a server, it takes them weeks to actually get that. That frustrates people. That frustrates developers. And so what's happening as a consequence of that is that a lot of developers are actually bypassing us IT folks and actually going directly to the public cloud because that can meet that instant gratification that they are used to in their private lives. And there's no reason that that same aspect of the cloud cannot be met in the context of a private cloud. And there are many legitimate reasons why customers want to stay on premises as opposed to go to the public cloud. Security and compliance happen to be just one of those reasons, but there are many, many reasons why customers want to stay on in the private cloud, right? The second thing is, in their day-to-day lives, when they log into google.com or when they go to Bing or when they go to outlook.com, if that thing is not operational, it's headline news. And you as an IT pro don't want to be headline news, at least not for this reason, right? And so their expectations of availability, resiliency are very high compared to what they were even 2 years back. Because they've grown up, they're seeing what's happening in the commercial world or in the consumer world, and they bring those same expectations into the workplace. The next thing is self-service is the norm today, right? Most people just want to be able to self-serve themselves. And developers want to say, look, I want to create a virtual machine. I want to create a website. Why do I need to open a ticket and somebody will do this when they get to it? That is an alien concept to people right now. And you want to be able to enable that, that agility as opposed to get in the way. Because if you get in the way, then they'll just bypass us and go off into the public clouds and so on and so forth, which creates a challenge for all of us in that space because then you can't be can't be ensured of the compliance and so on and so forth. And there are some power users who will say, look, I don't even want the portal, I just want a REST API. You give me the REST API and I will automate my creation of websites, VMs, or whatever the case may be, because I have my own tools to actually go do that. And these demands are put on IT pros day in and day out. And that is what the cloud means to these customers, right? But here is what gets in the way. Okay. Here is what gets in the way. Okay, that's what gets in the way. No, not the clicker, but the actual problem. So what happens is that, when you try and build up a cloud today, right, you'll basically hit some issue or the other, and then you'll start the dance of figuring out whether the problem happens to be in the operating system, it's a bug in the driver, then you need to go collect additional logs, and, the thing doesn't repro. And this just carries on and on and on. And that makes it really hard for you to operate efficiently a private cloud, right? And so when we set out to figure out how do we go solve this problem for the customers, we came up with 6 different facets of how it means to operate a private cloud. And these are 6 tenets that are fundamental to the operation of the cloud. And these we have learned after actually operating something like Microsoft Azure. So first and foremost is system architecture. That means when you design your cloud, you have to think of it from the ground up, right from the perspective of how is power being fed to those racks, what are the failure domains that the racks are going to live in, what is the probability of your disks failing, your network cards failing, your networking gear failing, your servers failing, the software failing, the portal failing, and so on and so forth. And you really have to go through in depth to understand what are the failure domains and then design to make sure that your system can handle all this resiliency. The second thing is, even after you design this, there will be failures, and hopefully you've designed the system well enough that it can handle the failure. But when a failure happens, that component has to be replaced. There is no choice. Eventually that component has to be replaced. You want to make sure that you're not in a situation that you've acquired a component which is very, very hard to replace, or it's very special. You want something that can be replaced very quickly and easily. The next thing is, and I will totally take responsibility just like any other software vendor should, is that we give you so many different options to actually deploy that it is impossible to find 2 different deployments of any private cloud to be identical to each other. every knob has been tweaked, and we all take pride in saying that, I tweaked that registry key. And that's fantastic as long as you continue to work there. But the day you leave, the knowledge about the registry key leaves along with you, and the next person is then left to deal with the consequences of the registry tweak that you had done. Right? And so we have to have a way to be able to deploy these over and over consistently. The next thing is, this is software, this is firmware. It's going to require patches. But in today's day and age, the technologies that exist, the plumbing exists for you to be able to patch your systems without having to bring down the tenant workloads. And that's something that we have really strived to achieve in the context of CPS. The next thing I'd point out is that even after you've done all of this, what you're doing this up is effectively to run workloads. And therefore, you need a way to be able to benefit all the workloads from this optimized deployment as well. You want to be able to deploy those workloads in an optimal manner. You want to be able to deploy them in a manner that they are in a supported configuration. That means, the disks are set up correctly, the DAGs are set up correctly for Exchange, for example, and so on and so forth. And the last thing is, we don't want customers to be in this situation where you're having to have like multiple IM windows open, 2 phones on your head, and trying to text somebody on your cell phone to figure out, is the problem with a particular NIC vendor, or with Dell or with HP or with Cisco or with Microsoft, and that's just a nightmare for all of you. And so rather than having to go over this rigmarole, you would really much rather prefer to say, look, you, Mr. Vendor, are responsible for supporting my cloud, and you will handle the support, and you will have those multiple phones open in case you want to. And so our response to solve this problem is Cloud Platform System. It's, if we call it Azure Consistent Cloud in a Box, which effectively means that you get the same portal, you get the similar APIs that you have in Azure. It's available in your data center. So it's a fully pre-integrated and deployed solution partnered with Dell hardware. It's running Windows Server 2012 R2, System Center 2012 R2, and Windows Azure Pack. And it uses software-defined technologies to give you the best from a price-performance standpoint. So it has the best of software-defined storage, it has software-defined networking, it has software-defined compute, and more importantly, it really has taken us in the product team a whole ton of work and effort to actually take the design point of how a large cloud like Azure is run. We build a private cloud based on those design principles and share that with you as a fully deployed and pre-integrated system. Not just the individual software that you get, it is literally the design that has gone into by the very team that owns these components, which CPS is constructed of, that you get CPS from. But the good part is, because it is built using Windows Server, System Center, and Windows Azure Pack, you all know the software stack. You know how to operate the software stack. So we've really strived to maintain that familiarity so you can actually operate it just as you would operate any other instance of the solution that you may have built or acquired from somewhere else. So here's some interesting data points that I want to talk to you about. CPS is an integrated system. So I'll give you some statistics which are important, which highlight, and these are not my statistics, by the way. These are statistics that IDC did some research. There's a URL there. It talked about buying a pre-integrated system actually gives you the many, many benefits. I'll point out 2 of them. The first and foremost is that it gives you about 97% reduction in downtime. That's huge. Just imagine what you all have been dealing with when you have to individually construct these systems. A 97% reduction in your downtime. And the next thing is that today's business requires you to actually have very quick return on investment. Right? With something like CPS, it reduces your deployment time. It basically allows you to get to market about 62% faster than if you were to try and construct a solution like this yourself. Right? These are 2 numbers I want you to take away. 97% reduction in downtime, 62% faster to be able to get your business to market. Huge improvements. The next thing I want to share with you is, what does it mean to operate a cloud? Right? So I'll give you examples of the Amazon cloud and the Microsoft cloud. We have a whole bunch of Microsoft engineers who are responsible for operating the cloud. You never see them, you don't know their email addresses, but they do exist. There are a large number of them whose responsibility it is to actually operate Azure, to operate Office 365, for example, right? And then you as consumers log in, go to the portal, and everything works just fine, right? And you are the consumer of the cloud. So there is a consumer of the cloud, and there's an operator of the cloud. But when you're operating a private cloud, you are the responsible entity who's going to basically deploy and engineer and manage that cloud. So replace this picture with your company's name, and then replace the Microsoft engineers with all of you sitting here, because you are going to be responsible for operating the cloud, right? And then your customers are the customers in IT who are or in various other parts of the organization who will log in that you've enabled to self-serve, and they'll be able to operate the capacity that you've set up for them, right? So think of this as the cloud model. You are operators, and then your consumers or your customers are the consumers of that particular cloud. And what CPS does is actually brings that cloud operating model on premises. And it does so by giving you all the familiar tools, right? So on the operator side, you're used to using VMM, Operations Manager, Data Protection Manager, right? And these are the tools that you will use to operate that cloud in CPS. And then from a tenant consumption perspective, we deploy CPS with the Windows Azure PAC portal, which is where the familiarity with Windows Azure or Microsoft Azure comes from. It's a simple web-based experience which allows your customers to be able to consume the capacity that you've laid out. So your customers can click on buttons, create VMs, create websites, create databases, and so on and so forth. While you, by virtue of the fact that this is a pre-deployed, pre-integrated system, can benefit from the 97% reduction in downtime and be efficient in being able to offer that service to your customers. Make sense? All right. So let's talk a little bit about the capabilities that you get when you buy CPS. First and foremost, you get the self-service experience. It's a self-service portal. You can access it through any browser, Mozilla, Firefox, Safari, doesn't matter, IE, Spartan, or Edge, I'm sorry. It's constructed using Windows Azure PAC. That's the same portal technology that powers Azure, but it's running in your premises, right? It comes fully pre-deployed and integrated when it shows up in your data center. So you don't have to go fiddle with wires. You don't have to do any deployment and installation. When it shows up, it's fully deployed. It's optimally designed to be fault tolerant. So we know exactly statistically the probability of disks failing, the network cards failing, and then we've designed the system to be able to handle those failures in CPS. It comes with integrated management, so it comes with a patching solution, which is one of the biggest challenges that customers face when trying to operate a private cloud. This patching solution actually automates the application of patches across the entire infrastructure of CPS. So we will automate the application of patches for WAP, for Windows Server, for System Center, for SQL Server that backs System Center. You get all those functionality as a part of this. And you get automation. So one of the simple tasks that somebody will ask you to do is to say, go rotate the passwords of the entire system. And I challenge you for all you to be able to do this without having to bring down the system in order to do that. And that's fundamental for you to be able to have a secure environment in your data centers. So rather than leave that as an exercise to you, we give you PowerShell automation, which basically automates the rotation of passwords across the entire CPS infrastructure. Let's talk a little bit from a capability perspective. So you have a tenant portal, which resides on top of a REST API. The REST API is available for you to either construct your own portals or actually offer it to your developer should they want to program against those APIs. That API layer sits on top of System Center, who stores all its state in the SQL database. It's a clustered SQL database instance. And all of this is running as VMs on Hyper-V. And the storage for Hyper-V hosts is provided through a scale-out file server subsystem, which is residing in the CPS rack. So it's exposed through SMB. That's where all the VMs place their VHDs. And then I talked about software-defined networking. So this CPS instance has software-defined networking built in. So when a customer clicks a few buttons to create a new network, that entire network is realized using software-defined networking. So you don't have to go touch the physical infrastructure. You do not have to go touch VLANs. Nothing. The customer is self-service. They create their isolation, and that isolated network is automatically set up inside CPS for you. From a capacity standpoint, this machine is powerful. It has 512 cores. It has 8 terabytes of RAM, and it has 156 terabytes of tiered storage. And when I say tiered storage, that means it's got a mix of SSDs and HDDs. And like any industry SAN, we have about 7.5 to 8% of our storage which is kept in SSD tiers versus HDD from a performance standpoint. Right? So let's talk a little more about how we offer the ability for you to deploy workloads, because at the end of the day, you're buying this to run these workloads. So what we've done is we've basically automated the deployment of these workloads for you. We automate the deployment of Exchange and give you those scripts. We automate the deployment of SQL Server. We automate the deployment of SharePoint. And we're going to be automating the deployment of Skype for Business fairly soon. Actually, we had already automated it, but they changed the name on us, and therefore it's taking a little longer. That's not the reason, but anyway. And so this is actually available as a web PI feed for you. You can use the web PI feed to actually download this automation and then deploy these systems in your data center. And that you can use even if you don't have CPS. So we make the automation of these workloads available to you even if you don't have CPS. And today, we'd like to announce that we also support VDI on top of CPS. So we support both Citrix VDI and the Microsoft VDI solution, both session-based VDI as well as client-based VDI on CPS. And you'll see us providing automation artifacts both for the Microsoft deployment of VDI as well as for Citrix Zen Desktop-based VDI on CPS. So let's take a quick tour and let's demo a few of these things. All right. So let's start our journey. Okay. I guess I need to connect again. No, it must have lost connection. So you know. There we go. All right, here we are into the console. So when your customers log into the Windows Azure Pack portal, here's what it looks like, right? So if you actually been to the Azure portal, it looks and feels just like this. So this is how your customers will consume the capacity that they have in CPS, right? So they have the ability, for example, to go here. They can create resources like websites, virtual machines, networks, SQL Server databases, MySQL databases, right? So that's a really simple web-based experience. You have, in this particular case, this user 1 happens to have created about 71 virtual machines. You have the ability to, so for example, select a particular virtual machine. Let's say I take this virtual machine. Let's take this virtual machine, right? And I get a nice dashboard for this virtual machine. And then I have the ability to actually contain, do simple operations on these virtual machines that are actually running here. Right? So let's take a Linux instance to see what we can do with that. So this happens to be a Linux Ubuntu instance that's running here, right? And I get this nice simple ability here to be able to start, stop, do simple operations with the virtual machine. I also have the ability for me to be able to connect to this virtual machine. And remember, this is a Linux virtual machine, so I'm not actually connecting through an RDP session, obviously, but I'm actually connecting through a simple console access right through the Hyper-V host. So even if a virtual machine happens to be wedged, in the BIOS state or something like that, you can actually get to your virtual machines and still allow the customers to be able to actually operate this. Like this one happens to be wedged for some reason. Right? You also have the ability to sort of create, resources right from here. So for example, if you want to create a simple SQL Server database, you can do this here, give it a name. Right? Give it an administrator password. Right? And that's it. And with these few clicks of a button, I've basically got to a point where the customer can create a simple database. Right? So I'm giving you examples of what it means to actually empower your users with self-service. You can very easily allow customers to be able to create virtual machines, websites and databases. So let me give you show you an example of what it means to be able to create virtual machines, for example. So I can go to this gallery. Now this will be a gallery that you as IT pros will populate for your customers. So in this case, it happens to be populated with Windows Server images. It happens to be populated with CentOS. It happens to be populated with WordPress. And all the kinds of applications that you want to be able to have deployed inside your enterprise or as a service provider can be populated inside the gallery. And by selecting this, the customer just has to provide some simple information, like I did for the case of the databases, and they have a fully deployed instance of Windows or Linux or the application that you want to offer to them as self-service. Right? Let me give you an example of what it takes to for VDI, for example. Let's go to the desktop, and this is a deployed instance of VDI here. So I've got the gateway set up here. Right? And here I'm set up as a user to be able to get both, session-based desktop and client-based desktop. So I can just click on this, right? And I get access to a VDI session that's been set up for me as a customer, right? So that's a VDI session that I have right up here for me. I happen to have a nice video that some of you might be interested in. So this is a time-lapse video when we were actually setting up the racks inside the show floor. So what I wanted to show you here was, with a few clicks of a button, as a customer, I actually have access to VDI. And that's a powerful message for you as customers who previously have not had the ability to actually get VDI as a supported workload on such optimized infrastructure. Right. So let's switch back to the session. All right, so let's take a look at what CPS really looks like, right? So those are actually pictures of a real CPS system. And I'd like to draw your attention to this last picture here, which actually has the picture of these disks here, right? So just to give you an example of the level of design we've done to actually get the system operational. So you will have disk failures in any system, right? But when you have a disk failure and you want to replace it, you don't want this entire JBOD to be pulled out on the rail. Because when you do that, what will happen is that the entire cable system will move back and forth in behind, and that will actually eventually cause some cable to get loose. So we've gone to that level of detail to really design the system to prevent that from happening. Because this particular JBOD, the way it's designed is the trays just slide out in an operational state. So I can basically, while this tray is serving up data traffic to the hosts, you can actually remove some of these disks and operate it very effectively. Right? So the goal has been really to design the system top down and make sure that you don't run into any challenges while in terms of operating this infrastructure. Right? So let's go on and show you a little bit about logically how is CPS laid out. So you acquire CPS in units of a rack. The smallest unit you can buy is 1 rack, and the first rack is this particular rack, right? And on this rack, you actually have storage, compute, and you have a networking edge, and you have physical networking gear, right? But on the first rack, we take 6 physical Hyper-V hosts, and we construct a Hyper-V host cluster on which to run all of the management software. So I talked about VMM, DPM, Operations Manager, Windows Azure Pack. A large part of that infrastructure runs on that 6-node Hyper-V host cluster. That is set aside separately for just running the management infrastructure. And then you have the remaining compute infrastructure on where you actually deploy the tenant workloads. That's the capacity that you have remaining for your ability to deploy tenant workloads. But you see that on rack 2, 3, and 4, you don't have the management cluster. Because the management cluster on the first rack is designed so it can handle the management of up to 4 racks and all the capacity that exists on all the way up to 4 racks. Right? And the networking edge is available on rack 1, and that depends upon how much traffic you have going in and out of the rack. You can either have these networking edge clusters on rack 2, 3, and 4, or you don't need to have them depending upon the capacity of network that you have going in and out from a customer standpoint. The storage itself is constructed using scale-out file server and storage spaces, which resides on JBODs. And I'll talk a little more in detail about what that architecture looks like. Okay? So from a capacity standpoint, each rack has 32 compute servers. It has a total of 512 cores. It has a total of 8 terabytes of storage. It has a total of 156 terabytes of workload storage, right, where you can run your workloads on, and 126 terabytes for backup storage. And I'll talk a little bit about the difference between the backup storage and the workload storage. They're configured differently. They have different amount of resiliency, and they have different amount of performance characteristics as well. Okay? And so from a physical rack perspective, this is what a rack looks like. And I've tried to separate out the networking aspects, the storage aspect, and the compute aspect. So let's start at the top. From a networking standpoint, right, it contains Dell networking gear. It contains Dell S4810P networking switches. It contains one S55 switch, which basically handles all the traffic that goes to the BMCs on those physical compute servers. And it contains an F5 load balancer. We use the 2200 chassis with the 2150 blades, which are deployed in highly available fashion. From a compute perspective, the Hyper-V hosts themselves basically run 2 Intel Ivy Bridge processors with 16 cores. It has 256 gigabytes of memory and a 200 gigabyte SSD, local SSD, where you boot the hypervisor from, right? But their ability to run VMs is off the storage. That's a shared storage subsystem, which is the scale-out file server itself. The physical compute contains 4 network ports. 2 of them are Mellanox NICs, and 2 of them are Chelsio NICs. The Chelsio NICs are what provide the RDMA access to the storage, and the Mellanox NICs are what provide NVGRE offload to the tenant traffic that's running for the virtual machines themselves. The storage itself, like I said, it consists of JBODs layered on top with a 4-node scale-out file server. The JBODs themselves actually use LSI 6-gig connectors to cross-connect to every single scale-out file server instance. And the scale-out file server itself exposes its storage through SMB3 to the actual Hyper-V hosts themselves. Right? And I think we've spoken a lot about the capacity that's available. Now, you can choose to carve up the capacity any way you choose to see fit, but from our perspective, we will support you running up to 2,000 virtual machines on a single rack. But it largely depends upon what the shape and size of a VMs is, and it is these numbers, the 512 cores, the memory and the storage, which will dictate what your VMs, number of your VMs that will be able to run on CPS. Okay? All right. So there are customers who walk up to us and says, what happens if I need additional storage? Well, we've got two answers for you. One is that Dell has just announced this capability called Dell Storage with Microsoft Storage Spaces. And what that really is, they've taken all the learnings from the storage that we have in CPS and made that available to customers outside to buy as an independent unit. So you as customers can buy that as an independent unit, and then you can actually have the VMs place their data VHDs on that particular storage. That's one option. The other option is that you may have some storage lying around which may have an iSCSI head, and that iSCSI head can be exposed through an iSCSI initiator from inside the VM, and you can get additional capacity inside the VM from that perspective as well. There's another option. I mean, customers also sometimes want to use this because they want to use their own backup software, and they want to be able to back up from inside the virtual machine to storage subsystems that are lying outside of CPS. So you can do that as well using this kind of a topology. Okay? So let's walk through CPS and its actual management cluster and how the logical stamp looks like. All right? So here I am in the virtual machine manager of a single rack that's actually running in the show floor right now. And as I talked about the fact that you have a compute cluster, you have an edge cluster, right? And you have a management cluster, right? And if you actually expand the management cluster, you will see that the management cluster itself, if you look at the details, right? It has 6 hosts, it has 33 virtual machines, and it has multiple VMM services running. These services are the services for the web portal, for operations manager, for AD, DNS, and so on and so forth. And I'll talk a little more in length at that itself. The compute cluster itself, if you actually go to the fabric view and you look at the compute cluster, you'll see that the compute cluster has all the physical capacity that's actually used for actually providing capacity to your tenant workloads. So this is running 24 hosts. It happens to be running 366 VMs at this point of time. And then from a storage perspective, if you actually expand and go actually look at the storage, you will see that it has a whole bunch of shares that have been set up. Some of them happen to be set up for backup storage, and if you actually go down, you'll actually see some of them are used for primary storage. Right? So I talked about 2 separate pools, the primary storage and the backup storage. So that's the separation point, and that's how you see it in your tools themselves. Right? Okay? Let's move back. All right, so the next thing we did, I talked about, how do we ensure that your cloud is robust and it withstands the test of time and doesn't have any issues when you have bugs in firmware or any of the software. So what we really did was we did a statistical analysis to find out what kinds of failures happen inside a data center, whether it happens to be the networking, the physical gear, the disks, and so on and so forth. And then we subject CPS racks to those failures that you're likely to encounter in a period of 1 year. We shrink it down from a time perspective and make a single rack subjected to those failures in 1 week, right? So we basically, and while we are doing this, we are actually doing these kind of things at the back of the rack, right? So there's somebody who's basically pulling power cables, pulling, network cables, and while we are doing this, we are live migrating VMs, and then we are still basically programmatically trying to create VMs, start VMs, stop VMs, and so on and so forth, with the intent of giving you the guarantee, and that's how we can stand behind CPS and make sure that from a support standpoint and from a quality standpoint, this CPS instance is highly robust and withstands all those failures that we claim that it should be able to withstand. Right? And as you can say, we simulate node failures, we shoot nodes in the head, we shoot disks in the head, and we remove NICs and so on and so forth to make sure that you're assured of the quality when you get the system. So let's go deeper into each one of those clusters so you can understand how is CPS actually constructed, right? So first and foremost, let's talk a little bit about the storage cluster itself. Like I said, the storage cluster is a 4-node scale-out file server backed by JBODs, right? And the 4-node scale-out file server exposes storage using an SMB3 protocol to the Hyper-V hosts themselves. So the Hyper-V hosts place the VMs, the VHDs of the VMs on the scale-out file server cluster, right? And the storage itself is constructed using JBODs, and the software that's running on those 4-node systems is basically Windows Server Storage Spaces, which basically aggregates all the capacity from those disks, layers it, creates pools out of the top of that, and then layers a scale-out file server on top of that subsystem. And that's how the VMs basically access their storage. And the VMs, the Hyper-V hosts themselves are connected using an RDMA NIC. I talked about this previously, the Chelsio NICs, which provide high bandwidth, low latency connectivity from the hypervisor to the storage subsystem. That's how the Hyper-V hosts access that storage. The next thing that customers ask us a lot, it's great that you're using storage spaces, give me an indication of what performance looks like. So a couple of experiments. These two experiments, the first one, the first chart, shows you the performance, the read performance that you can get when you're trying to get 4K IOPS out of the subsystem. And this is storage performance as measured from inside the virtual machine. As you can see here, you can get about 1 million IOPS from inside virtual machines when you're just doing pure read. But that, in all honesty, is not a real reflection of how workloads really operate. You're likely to find a mix of read and write. And so the second chart shows you the details of a 70% read-write mix. 70% read, 30% write of 4K IOPS measured from inside the VMs. And as you can see, we can get close to 321,000 IOPS in CPS. Another way to look at this is to subject the storage subsystem to a boot storm. So we basically loaded up the system with 1800 VMs and tried to boot all of them at the same time, right? And basically, as you see this chart, it shows that we were able to boot 1800 of them in less than 25 seconds. And so that gives us the confidence that what we have got from a storage performance standpoint meets the demanding needs that your workloads are going to put on top of CPS, right? Let's talk a little more about networking, right? So it's a flat network. In fact, the networking design of CPS Stamp is actually picked right from Azure. It has very high amount of bandwidth between the multiple racks that exist inside CPS, right? We use 2 NICs for the tenant traffic. They are actually teamed together in a single team. So the maximum bandwidth that you can get out of a single physical host is 20 gigabits, right? And then we have 2 separate NICs which provide the access from the Hyper-V host to the storage subsystem. And then you actually have the cross connections. So each of these NICs are connected to two switches. So we have 2 switches for the data center networks, and we have 2 switches for the tenant networks. And then we have a third layer of switches which basically aggregates, which act like aggregate switches across all the stamps themselves, right? From a performance standpoint, the second chart on the right shows you the performance across different types of networking traffic. The first one is about 2 VMs sitting in CPS trying to talk to each other. So if you recollect, I talked about the fact that a single CPS rack has 2, or a single Hyper-V host has 2 10 gig NICs. That means the maximum data that you can pump out through a CPS rack is 20 gigabits, or a CPS host is 20 gigabits. That's the physical capacity that you have on the host available. And this number of 18 gigabits is what you can get from inside VMs. 2 VMs you deploy on CPS, that's the amount of traffic that we can pump out between 2 VMs. And the rest of it accounts for the overhead. So this is pretty much close to line rate that you can get between on the system. The rest of the charts are for different kinds of traffic. So remember, you're running NVGRE inside the rack. But when you go outside the rack and want to access any capacity or service outside, so for example, you may have a situation where the website, the front end is running inside CPS, and you've got a back-end database system which is running on some physical server outside of CPS. At that point of time, you'll have to basically traverse the network edge gateway of CPS and go talk to that physical server, if you will. You'll, at that point of time, traverse through a forwarding gateway. So the forwarding gateway basically now gives you, just look at this number, 10 gigabits per second. So we are doing translation between NVGRE to the actual packet as it needs to go out and still being able to get 10 gigabits out of this. And the last chart, which is about 1.8 gigabits, is where if you want to use CPS as an end destination endpoint for a site-to-site VPN tunnel. So for example, if you're a service provider, right, and you're providing capacity to your customers, and the customer has got their own data center, and you want to establish a VPN tunnel between the customer and the data center of the service provider. At that point of time, you can get 1.8 gigabits. This is an IPsec tunnel. So even with IPsec, we can get about 1.8 gigabits through that tunnel. So pretty happy with the performance. And we get this because we've been able to design the system end-to-end and handle the NVGRE off or offload the NVGRE processing onto the actual Mellanox NIC itself. So let's talk a little more about the management cluster itself, because this is indeed the heart of the system which basically manages it, offers the services up to customers. So this is a 6-node Hyper-V host cluster which actually runs all of the management software. I mean, in reality, there are actually 10 VMs which run on the compute cluster, which offer up the web portal itself. The web API and the web tenant portal actually run on the tenant on the tenant portal, because we don't want to expose any of the direct internet-facing traffic directly on the management cluster from a security standpoint. So everything that's deployed inside the management cluster is deployed in a highly available fashion, and everything is deployed in a highly available VM, except these 3 instances of AD, DNS, and DHCP, right? There is a circular dependency, because when CPS has to come up and the clusters have to come up, they need to be able to talk to AD. But if the AD VMs themselves are running off of the shared storage, which is a cluster itself, you have a circular dependency. So what we did was we basically create 3 separate VMs of AD, DNS, and DHCP. They run on 3 separate physical hosts, and they basically replicate data between each other, but they run off of the local SSD. Right? So those are the only VMs that you have in CPS which are not sort of, so to speak, clustered. Right? And the rest of the VMs are all running in highly available VMs. But even then, you will see that from an operations manager perspective, we run 3 instances of OM, which can basically provide you a resilient deployment of operations manager, because that's what provides you the monitoring capabilities inside CPS. You have the WAP tenant portal. We have the SPF API layer that's deployed here. We have VMM, which is deployed as a highly available cluster. And then you have a SQL cluster, which is a 4-node guest cluster deployed on shared VHDX. That's how we actually get the clustered capability for SQL inside CPS. From a management services standpoint, we offer deployment and configuration using VMM. We offer the WAP Service Administrators portal, where you actually go create plans. We have DPM, both for the management cluster backup as well as for the tenant backup. We have Operations Manager, which is utilized for providing monitoring services to CPS. And then we have SMA automation. I gave you an example of the password reset, for example. That's the kind of automation that we provide inside SMA to automate mundane tasks that you as IT operators are faced with. And then we offer patching and update. So we offer a PowerShell-based automation engine, which basically orchestrates the application of patches across all of CPS. Today, we don't automate the application of firmware and BIOS, but by the end of this calendar year, we will also automate the application of firmware and BIOS patches in CPS. So you'll be able to automate all of it while none of the tenant workloads will go down. Today, we give you detailed instructions on how to do it for the firmware and BIOS, and even those detailed instructions will not let the tenant workload go down, right? But eventually, we will automate even that. So you just have a single PowerShell script that you run, and it will apply the automation across the entire CPS instance. And then included in CPS, if you buy 2 instances of CPS, you have disaster recovery included as a capability inside CPS as well. So if you want to protect your primary data center with a secondary data center, you buy a second CPS instance and then start replicating using Hyper-V Replica between the primary site and the secondary site. Right? So let's give you a little bit of a demo on the management services. And in fact, the demo I'm going to give you is what happened was that when we shipped, we have 2 racks that we have shipped here. And when one of the racks showed up here, we found that one of the disks was bad in that rack. So obviously the team which had come here, texted me and said, "Hey, Vijay, can you get a bunch of disks?" So I said, "Okay, I'll get the disks, but we won't replace the disks because I want to show you what resiliency really means in CPS, right?" So I'll go into the OM console of CPS, right? And if you actually see this particular alert, you'll see that this alert says that a particular disk is not operational, right? So you'll see that the disk has experienced an error. Yet, if you go by the racks or all the demos that I've showed you, they're actually running off of the same rack. So this is an example of where the design of the system really matters, right? I'm sorry. But you as operators eventually have to take action on something like this, right? And so we ship, a simple script. And this script, for example, I've got this PowerShell script. It's a very simple PowerShell script. What I'll enter into a PowerShell session with that particular host name that I got from there. And then I'll run this PowerShell script, which will basically spew out all the physical disks that are there in this particular system. And if I scroll up, you'll actually see this particular, you'll see this particular disk here, which has lost communication. So now you as a customer know that I've got a disk that's lost, I've got a disk that's bad. All you need to do is pick up the phone and call Microsoft support and tell them that, look, I've got the situation, I've got a disk that's failed. And Microsoft will then will coordinate with Dell, and we'll make sure that a disk is shipped out to you so that a technician will actually then replace the disk, and then the disk will get rebuilt, it'll be added back to the pool, and it'll be healthy from that point onwards, right? So that's just an example of the end-to-end solution orientation of this system. Another example I'll show you is the actual operations manager dashboards themselves, right? So I'll go into OM here, and you'll see sort of the OM dashboard that we built. Now this is a standard VMM dashboard, but if you actually go up here, you'll find here, if you find up here, you'll find CPS dashboards. So these are special dashboards that have been constructed for CPS that we ship as a part of CPS, right? And they have been tuned to make sure that erroneous alerts don't spew all sorts of alerts at you to basically cause you concern. And you can actually look at the CPS system health dashboard, and this will give you an indication of the entire health of the system, because we know the storage subsystem, the compute subsystem, the networking subsystem. We can actually provide you a dashboard specifically tuned for CPS, right? Another example of a capability that I want to give you is reporting and chargeback. Lots of customers today ask us for the ability to charge back their customers on usage, right? So there is a service reporting capability that ships as a part of CPS, and I've just plugged in this Excel spreadsheet to go get that data from that service reporting cube. And effectively here, you can you can see that I'm showing you that this particular user 1, right, happens to be running this particular VM, and it'll give you all the statistics about the VM, the number of cores, and so on and so forth. So you as a service provider, as a customer, can then decide how you want to be able to charge your customers based on usage. It's a pretty big thing as a part of the cloud. Okay? Let's head back into the deck. Right? So here's another capability that's absolutely vital to keep the CPS systems up and running. Now there is another session later on this week about operating CPS, which really goes into details about all the information for monitoring and backup and patching and update. But I at least want to highlight this particular functionality. So what we do is, first of all, we basically aggregate patches from firmware, BIOS, Windows Server, System Center, across a period of about a quarter, right? We aggregate all those patches, right? and then we basically validate them inside Microsoft. We've got multiple CPS instances running inside Microsoft, so we validate all those patches on those CPS instances to make sure that they operate correctly. Then inside Microsoft, we've got a very large private cloud. It's called Nebula. It has a capacity of about 90,000 VMs. And on a daily basis, about 25,000 of them are basically spun up and spun down. A chunk of that capacity, in fact, about 6 racks of that capacity is now running on CPS. So we then apply this patch to that particular Nebula rack system. And it's only after that validation that we actually ship this automation package and the actual patches themselves to you as a customer. So then you basically just run the PowerShell script. It basically removes the VMs from a Hyper-V host, puts the host into maintenance mode, both in OM and VMM, then basically applies those patches, reboots the system if required, attaches it back to the cluster, and then removes the maintenance flag off of that particular host, so the VMs basically come back onto that. So that gives you, the ability to run the CPS patching without having to bring down any tenant workloads. So we've been able to do this. We shipped our first CPS patch, update 1, on 31st of March. It's been applied to the customers that are out there. And the shortest run was about 15 hours, which it took for the software patching, where we were able to automate the application of the patches across the entire 2-rack system in 15 hours. And none of the tenant workloads went down while that was happening. So if you were a tenant VM, operating in the VM, you wouldn't even notice that something was going on in the back end. Right? The next thing I want to talk about is capability that's there in CPS. I talked about disaster recovery. So you need to buy 2 instances of CPS, put them in 2 different data centers, attach them with some networking infrastructure, so you can replicate between the primary site and the secondary site using Hyper-V Replica. There's no additional charge for this, right? And then there is a SaaS capability called Azure Site Recovery, where you basically write your plans to be able to do disaster recovery. So for example, if you want to be able to say, I want to run 3 scripts before I do disaster recovery, then do the actual failover, and then run 10 more scripts after that, that's where you can do all this automation from a disaster recovery standpoint. Now this was what we shipped when we shipped a CPS. That was about 6 months back. And then as we spoke to customers, they said, look, this is great, because I've got customers who've got primary and secondary data centers. But I've also got where I don't have a secondary data center. So why don't you give me this ability to fail over directly into Microsoft Azure? So we said that's absolutely fine. So today we are actually announcing the ability for you to actually do disaster recovery for CPS directly into Azure, right? In addition to that, there was another capability that customers asked us for, which is to say that, look, it's great that you give me a copy of backup data on CPS, but I've got compliance needs, which require me to keep a copy of the data off CPS as well, right? So give me some ability to do that. And so we are also announcing the ability for you to get off-stamp backup copies in CPS as well. A couple of things that I would highlight as a part of this, right? So this isn't a product that we release and then the next one comes, 1 or 2 years later and gets new functionality. As you see that in each update that we release, and I'll show a little more later, we're going to keep adding functionality based on the feedback from all of you. Okay? So what will happen now is that instead of having to replicate directly into a CPS instance, you'll be able to replicate directly into Azure and then fail over your workloads and run them in Microsoft Azure. And in fact, in the operating CPS session, there are more details that we will share on how this actually works. Okay? Or more detail on DR we'll share as a part of that conversation. Now this slide shows a little more on the CPS roadmap itself, right? So as I said, CPS 1.0 is supported like any Microsoft product, 5 years for standard support, which will run all the way up to November 2019. And then we'll offer about extended support for approximately 3 years, which goes to the end of July. And what I really mean to say by this is that the entire appliance is supported from your perspective as one unit. So you don't have to worry about System Center going out of support, or Windows Server going out of support, or SQL going out of support. That's for us to take care of. When you buy CPS, here are the dates that you need to be worried about. CPS 1.0 goes out of mainline support in November 2019, and then in July 2022, it'll go out of extended support. So you buy CPS, and we'll make sure that we support you to run it to ground and make sure that you get the stability that you desire on the infrastructure side. Okay? And then we'll keep adding new capabilities and functionality as you keep providing feedback to us. So for example, we shipped update 1, we added support for German and French in the portal, and we shipped an aggregation of Windows Server, System Center, and firmware patches. Right? We're going to ship update 2 in August, and that's where you'll get off-stamp backup, you'll get DR to Azure, you'll get encryption of data at rest using BitLocker, and of course we'll actually add more functionality from, or rather we'll provide all the packages for the updates themselves. And then in update 3, we'll do a hardware refresh. We'll provide more automation for deployment of PaaS services, right? So today, if you have to set up, the SQL farm or the MySQL farm or the website farm, today, we give you a good document to actually make that happen, but we're going to give you automation so you can then automate the deployment of the backend farm as well. So we'll offer more PaaS services or easily give you the ability for you to offer PaaS services. And then based on your feedback, we'll continue to add capabilities. And so roughly every 3 to 4 times a year, we'll update CPS, and we'll do that right till November 2019. And at that point of time, like with every Microsoft product, we'll switch to only providing you security updates. But even with the security updates, we will provide them using the patching and update framework, so you'll be able to apply those patches in an automated fashion. And then at the end of 2022, when it goes out of support, by then hopefully you have bought a second instance of CPS and you can drain and move on to the second instance of CPS. So you also heard a lot about the Microsoft Azure Stack, and many people have walked up to us at the booth and asked us, what are you going to do about CPS in the Microsoft Azure Stack? So absolutely, we are going to build a CPS using the Microsoft Azure Stack that will be available once Microsoft Azure Stack itself is available. Okay? So what's going on right now? So right now, it's been deployed at multiple customer sites, both in the US and in Europe. There are publicly referenceable customers. It's deployed at a Capgemini in Netherlands. It's deployed at a very large service provider called NTTX in the UK. And it's deployed at 2 other entities in Microsoft. Unfortunately, we can't share details of those customers because of confidentiality, but this customer reference is available if you actually go onto the Microsoft website called microsoft.com/CPS. It's available in USA, Canada, and Europe. It's available in a total of 31 countries. And we've got the detailed list down here. Right? So in summary, basically CPS is a ready-to-run Azure Consistent Cloud in your data center. It's Microsoft validated. That means we do all the validation. We support the system. That means if you have a problem, you just pick up the phone and call Microsoft. Regardless of whether it happens to be a hardware issue or a software issue, we own the responsibility of driving that to close, right, and giving you the fix. And then it uses software-defined innovations to make sure that you get the best out of the system. Right? So we've got 4 other sessions specifically on CPS. There's a session on operating CPS. There's an architectural deep dive on CPS. There's a deep dive on CPS networking because there's a lot to basically grasp there. And then there's more about how you can deploy automation, use automation to deploy the workloads on top of CPS. Right? So here's an Azure Challenge sweepstakes. We'd love you to participate as a part of this as well. Okay? All right, and so we've got about 10 minutes or so. I'd be happy to take questions at this point of time. Yeah. So the question is, will the Active Directory integration work with your own internal Active Directory? Absolutely. So CPS actually ships with an Active Directory domain, but when it shows up in your data center, along with it comes a Microsoft and a Dell engineer. And the Microsoft engineer will work with you to basically establish bidirectional trust between the Active Directory domain that's inside CPS and your Active Directory domains. And so then you can use your credentials to be able to access CPS. That's one. The second is that there is an ADFS system in CPS as well. And so by establishing ADFS trust, when your customers log into the portal, you can do that using your credentials as well. It's a separate forest that's a trusted forest. Yeah, we haven't seen, we've deployed this multiple times. Love to get more insight, but we haven't seen any problems as a result of that. Yep. Sorry? So the question is, are there any plans to bring it to Australia? Not right now. And I'll tell you why, what it takes for us to bring CPS to a particular geography. The first and foremost thing is that, we stand behind from a support standpoint. So we want to make sure that when you pick up the phone and call Microsoft, the support personnel are in a time zone that's friendly to you. We don't have that support infrastructure set up for CPS in APAC. The second is that when we have to ship a rack to you, right? I told you the way this rack is constructed is the components show up on an integration site. It's literally racked and stacked there. And then we remotely log in and deploy the software on that. That integration sites, there are only 2 of them in the world right now. One in Dublin and one in Austin, Texas. So we have to go establish that in APAC. So what we want to do first is make sure that the geographies that we are in currently, we can serve, and then we can expand out to other countries. But if you as a customer are willing to buy the rack in US and ship it to Australia, right? I mean, there are some challenges that you incur as a part of, the duties and so on and so forth. But if you're willing to do that, we'd be happy to work with you to go make that happen. So the question is about money. So the list price, right, for a CPS rack is 1.6 million US dollars, right? But that's list price. So for those of you who are in the know of how to buy hardware, you know the level of discounting that you can get when you actually buy hardware. Yeah. Any other questions? Yeah, sorry.
So you're using a Windows 2012 ARM now.
That's right. So the question is, are you going to upgrade everything once to Windows Server 2016? So we will definitely allow you to run Windows Server 2016 in the VM, right? But we're going to be very mindful about what we do on the host side. Think of it, think of when you go to Azure or when you go to Amazon, do you really ask the question about what version of the hypervisor of Zen is running in Amazon? Or what version of Windows Server is powering Azure? You really don't. You really worry about the stability of the infrastructure and make sure that the workload that you want to run, whether it happens to be Linux or Windows, is available in the tenant guest space. So that's the way we want people to think of when they think of CPS. And so we'll give you the ability to run Windows Server 2016 as a guest, but on the host side, we would like to be far more conservative on that. But we will certainly, like I said, we'll have a version of CPS that's constructed using Microsoft Azure Stack. And Microsoft Azure Stack does include the latest version of the OS. But that'll be a new CPS instance. Yeah.
Any thoughts for hybrid cloud support?
So the question are, any thoughts for hybrid cloud support? Well, actually, hybrid cloud in some sense is supported already because we do allow replication into Azure, right? So we do allow replication into Azure. But I'm guessing what you really are talking about is the ability to sit in front of a portal and manage both my Azure resources and on-prem resources. So that's functionality that's possibly slated to come in some future version of the portal. And when that's available, it'll be available in CPS as well. Can you do it with App Controller? If you want to deploy App Controller, you can deploy App Controller here. But I think a better choice would be to actually, there are third parties who've actually written providers in Windows Azure PAC. There is a company called Conube that actually offers you the ability to actually use a provider under Windows Azure PAC and offers the same capability. So I would encourage you to go down the Windows Azure PAC route as opposed to the App Controller route. Yeah. Yes. Sorry, what's the current limiting factor for?
Current limiting factor for supporting Skype for Business on CPS.
So the question is, what's the current limiting factor? There isn't any limiting factor, but from our perspective, right, before we stand behind a workload that's running on CPS, we want to do all the automation and we ought to do all the validation. So we are going through that exercise.
So is it going to work with SDN in Skype for Business?
That's what we have to go, work through from a performance standpoint, work through the deployment standpoint, and then we'll support it. That's why we're not supporting it yet. But when we do, we'll give you all the automation so it works with all the SDN, all the NVGRE networks, and so on and so forth. Yeah. Yes?
Is there a method that we can use for deploying security patches on a more frequent basis?
So the question is there a method that we can use to deploy security patches on a more frequent basis? No. We do not want you to patch CPS on your own. If there is a security patch, we will actually provide you the patch if it is applicable to the infrastructure. So we basically are in touch with MSRC, and if a critical patch goes out and it's applicable to CPS, we will turn around and give you the CPS patch with the automation framework, so it'll apply across all of CPS. Right? So we're not going to leave you, on the street to go do it yourself, but doing it yourself will be a bad idea because that's what causes systems to go down eventually. But we will turn around and if it's a critical fact, we'll turn around and give it to you. Yes.
I'm curious because of ASR limitations, do you use G1 VMs or Gen 2 VMs?
So if you want to be able to replicate into Azure directly, then you can't use Gen 2 VMs. You have to use Gen 1 VMs.
So do you by default use Gen 2 VMs?
It's your choice. You can actually use, today, remember, VM roles don't support Gen 2 VMs, right? But VMM is going to fix that in, I think, UR6 or UR7. And so you'll have support for Gen 2 VMs. In which case, you'll have to make sure that if you want to do Gen 2 support, then you don't, then you handle that appropriately.
So is Azure going to ever natively support Gen 2?
It's on their roadmap, but I can't speak for when exactly that's going to happen. Any plans to broaden CPS for other countries? Which country are you referring to? At this point of time, we don't have plans, but we're happy to come by and talk with us, and we'll chat with you. Right? So, like I said, if you want to buy CPS in US and ship it there, we can work out some modality, but that can be challenging because of import duties, particularly in some of the LATAM countries. Yeah. So the question is, are the specs available for the small version of CPS? I mean, we've shared everything about CPS. Or what specifically are you looking for, just so I'm clear? Okay. Yeah, so the management pack for CPS is not available outside of CPS, but we are figuring out how to make that more broadly available. That's good feedback. We'll see what we can do. We've been working on figuring out how to slowly give that out, but that's good feedback. We take that. Sorry? No, it's actually the whole when I showed the cluster health and so. But the storage MP is out, by the way. We released the storage spaces MP, and that storage spaces MP actually was built because of CPS, and we released it to the customers. But I know what you're referring to. You're referring to the cluster health and all of that stuff, the full management cluster health. Yeah. So the storage spaces MP has been released. Yes, that has been released. Yes, that has been released. Yeah. Any other questions? All right, folks, thank you so much for coming by. Please complete the... thank you.